most production incidents don't start with clean alerts. They start with a lot of noise. CPU alert, memory alert, database alert, API latency alert, disk warning, the list goes on. Everything starts screaming at same time. And at midnight, the real question is not do we have alerts? The real question is which particular alert should we fix first? Because during a real production incident, time is limited. And if you are chasing the wrong alert, which many of us do, you can easily waste 30 to 45 minutes of time while customers are still affected. So, in today's video, we are going to build an AI incident triage assistant. By the end of this video, you will learn how to generate realistic production alerts, how incident triage actually works in large environments, how to score alerts using engineering rules before involving AI, how to identify customer impacting incidents automatically, how to build a risk scoring engine using Python, how to use Ollama and Mistral locally, how to create structured AI incident reports, how to separate root cause candidates from symptoms, how to keep humans in control of production decisions, how to build a complete AI powered DevOps project that you can adapt in your own environments. And the best part is that this isn't just another AI prompt. This is the practical workflow. You can replace the fake alerts with Prometheus alerts, Grafana alerts, Datadog. I mean, it can be any kind of tool or technology that you are using in your own projects. The architecture will remain the same. But just like the previous project, we are not going to blindly trust AI. We are going to do this properly. Of course, every company has different services, different alert names, severity levels, and escalation rules. So you will need to adjust this for your particular environment, but the architecture absolutely works. If you enjoy practical AI and DevOps projects like this, hit the like button, subscribe if you are not already subscribed, and comment triage if you want me to make this full project public. Also, I need at least 100 comments on this project. Now, let's build it from scratch. First, let's talk about the real problem. In many companies, the problem is not that monitoring is missing. The problem is monitoring creates too much noise. I mean, if you are working in an organization or a project, definitely you can relate to whatever I'm trying to tell here. If not, that is also fine. You may have Prometheus or Grafana or Azure Monitor or maybe Datadog. Lot of alert rules, emails, channels. I mean, there is a lot. Everything here is, let's say, connected. But when something breaks, You don't get one perfect alert saying, here is the root cause. Instead, you get many related alerts. Maybe the database slows, or maybe API starts returning, some errors, something like 500 errors, or maybe checkout service latency increases, CPU goes high. So, as an engineer, you will see 50 different alerts and doesn't know what exactly to do first. This is exactly where an AI assistant can help you. Not replacing the engineer, but just organizing the chaos. The goal is not automatic remediation, but better triage. Now let's look at the project structure. The project structure is already ready. I did prepare everything. We have alerts folder, we have reports wherein all the reports will go. We have AI triage file, and we have generate alerts file, incident report file, risk scoring.py file. I can run this command real quick and show you the structure so that it's very clear. Now let's draw the architecture real quick. I'm going to go back to my blackboard once again. So the architecture is very, very simple. Alerts are, let's say, the first step, followed by we are going to do some risk scoring, and then we will have alert summary, AI triage, and then final incident report. Human validation is the last step. As I said, the architecture is very, very simple. We'll have alerts, we have some risk scoring system, alert summary, AI triage, final incident report, human validation. Notice again, AI is not the first step. We don't just throw 100 alerts and ask for the output, but we apply some engineering logic first. So that will happen here. Now let's jump back to our Visual Studio Code. First things first. To make this work, we need some alerts, right? First, we are going to generate the production alerts. For that, I'm going to say Python 3 generate alerts.py. Press enter. In a real company, these alerts come from Prometheus, Grafana, CloudWatch, Azure Monitor, or any other internal monitoring system. For this demo, I am trying to generate it from a Python script. The important thing here is not the alert source. Okay, it can be anything. The important thing I would like to talk here is, let's say, the full workflow that we are doing today. Now we have the data ready. Let's try to read that real quick. For that, I'm going to say cat space alerts followed by alerts.json, and I would like to read, let's say, first few lines. So I would say head 40. Press enter. Now, if you look at the structure, each alert has an alert ID with the number, followed by we have some timestamp, a service, a team, criticality, environment, region, severity. This is exactly what you are going to see in real production environments. And also, we can see the signal type here, latency, for example. This is very close to the type of metadata you would want in a real alerting workflow. Because if you only know only the CPU usage, for example, that is not enough. CPU high on a dev service is not the same as database unavailable in production. Now let's try to open the code real quick. So this is my generate alert.py script. So if you look at this very carefully, we define a list of services here: Postgres, auth, checkout. I mean, according to the environment, you can define that here. And also you can write it down, the criticality, the team, all the details can be, let's say, provided here. Then we define alert templates here. For example, we are trying to include database unavailable, connection pool exhausted, 500 spike, then checkout latency. The list goes on here: payment failure, pod restart loop, and all of that stuff. The script randomly generates 120 alerts, but I also intentionally make a few alerts more serious. For example, if you can see, Postgres is unavailable from application nodes and also the customer impact. This particular part gives us a realistic incident storyline, because in a real outage, not every alert has the same importance. As I said, we see a lot of noise. Now let's go back to our second part. Let me clear the screen and I'm going to run risk scoring.py. Now, this is, let's say, the scoring engine. This is one of the most important parts of this particular project. Many people would try to send raw alerts directly to AI. I am not doing that here. Before AI gets involved, we should apply deterministic engineering logic here. So, if you look at here very carefully, we have top 5 alerts with a priority P1. For example, score is, let's say, 445. This is not AI. This is just pure engineering, and that's very important. Now let's look at the risk scoring.py. Let's walk through this particular file at a very high level. We start with score maps. For example, if you can see, we have a severity score, criticality score, signal score. High severity gets fewer points, medium and low gets lower scores. Then we score service criticality. A critical service like PostgreSDB or payment service gets more weight than a low impact service. Then we are going to score signal type. Availability and errors are more important than maintenance warnings. We are trying to calculate the risk score here. We are using the severity score, criticality score, signal score. Then we are giving the environment details here. For example, production means I'm going to give more 75 points here. Followed by, we are trying to add extra score for customer impact, and also the status firing is, let's say, few more points. This is simple but very powerful, because this is how real triage happens. You don't look at alerts equally. You first ask, is it, let's say, production, or maybe is it, let's say, customer impact, or is it, let's say, still firing, is the service critical? I mean, you'll ask multiple questions. Is this a symptom or a root cause? This particular script then sorts the alerts by risk score and writes a summary report, as you've seen in the terminal. Now let's look at that particular report that got generated. For that, I'm going to say reports alert summary.md. Press enter. Now let's look at this very carefully. If you see alert triage summary, this summary was generated before AI analysis. We have total alerts 120, P1 59, P2 13, P334, P414. And also we can see the details here. Severity counts. Critical, we have 49, high 24, medium and low. Most noisy services. And the top 20 risk scored alerts. This is already useful without AI, and that is the point. If your system is useless without AI, AI will not magically fix it. AI should improve a good workflow, it should not hide a bad workflow. This particular summary reduces a lot of noise if you look very carefully. Instead of sending 120 raw alerts, we send the most important summary. Again, we are trying to follow the same pattern as project 1. Better data first, AI will come second. Now let's talk about the local model, Ollama list. For this project, once again, I am going to use the same Mistral model which I did with my previous project. You could replace with another model. You could use GPT, Claude, Gemini. It's up to you. The model is not the main point here. The whole workflow is what matters a lot here. I am using a local model because many companies are careful about sending operational data, especially outside their environment. Even though this is, let's say, kind of, a fake alerts which I try to generate, I don't want to use, any other models. I'm going with the local models. Now, let's try to run the triage script. Python 3 AI triage.py. This is where the real magic happens. Now we are trying to involve the AI. We are trying to send summarized alerts to a local AI model. As I said, we are not sending raw random alerts. We are sending a structured alert summary. The AI will only receive what we send, for example, top alerts, risk score, whatever we saw in that summary file. Now the AI has a lot of context to help us reason, but not so much noise that it gets confused. Now let's look at the AI triage.py file. Once again, this is very simple. The first thing it does is just read the alert summary report. Then it builds a prompt. The prompt tells the model, you are a senior incident commander and site reliability engineer. You are reviewing a summarized and risk scored alert report. Important rules we are trying to give here, and also return the answer in the exact structure, because we don't want a generic chatbot answer. We want incident thinking. For example, if you see recommended incident priority P1, P2, P3, top incidents to investigate, likely root cause, escalation recommendations. I mean, we gave a lot of details in this particular prompt. This particular thing matters a lot because during an incident, nobody wants a random paragraph. We need a proper structured output like this. We need to know why it matters. Do we have any kind of evidence for this? Customer impact, how big is this? Recommended owner or team, should we escalate or not? This particular script sends the prompt to Ollama, and also if you look here, we are trying to save this report. Again, we save the output as an artifact, not just terminal text that you saw just now, because in real incidents, reports matter a lot. You want to paste this particular report into Slack channel, or maybe attach it to an incident ticket, or use it as a post-mortem. This can be used, let's say, in multiple different ways. So it is better always to store this particular file. It can be useful in future incidents as well if you come across the same thing. Now let's look at the report very clearly. What do we have in the report? I will say cat slash reports AI triage report.md. Now look at this executive summary. There are a significant number of critical and high priority incidents affecting multiple services, with the majority of alerts being related to PostgreSQL database, HTTP 500 errors. Most noisy services are PostgreSDB, Redis cache, worker queue, all service, payment service, marketing site. I can see multiple different services. Recommended incident priority P1. Top incidents to investigate first. P1 score 445, database unavailable, alert ID I can see. Why it matters? PostgreSQL is the primary database for multiple services, and its unavailability can cause widespread service disruptions. Evidence: Postgres is unavailable from application nodes. Customer impact is true. Recommended owner or team database. So if you look at the output, we have the proper priority here. We can see the likely root cause candidate. We can see the symptoms as well. And also, I see immediate next commands or checks. Investigate Postgres unavailability and exhaustion of connection pool in affected this particular regions. Analyze HTTP 500 error logs, and also escalation recommendation we have. If the root cause cannot be identified within a reasonable time frame, escalate incident to on-call manager and engage the appropriate teams for further analysis and resolution. Finally, we have human validation checklist as well. Confirm Postgres unavailability, exhaustion, validate any adjustment made to server resources. Confidence score 80% based on high volume of related alerts and the impact on multiple services. This is where AI becomes useful. It is not just listing alerts, it is explaining priority. That's the value. Alerting systems tell you something is wrong. Triage tells you what matters most. That difference is, let's say, very, very huge. Now we generate the final incident report. This combines the AI triage output with the pre-AI alert summary. Press enter. Now we have this written into an MD file, and it adds a human approval section. This is very, very important here because AI should not be the final decision maker, especially in production environments. Now let's try to understand incident underscore report.py file. Again, this is very, very simple. We are not doing a lot of stuff here. For example, we are just trying to take the summary file, AI report file, and we are trying to generate the final report file, combining these two files. Then we are trying to give an important note here. This report is generated by human in the loop AI incident triage workflow. Scrolling down, I can see pre-alert summary followed by human approval section as well. Before taking actions, use this. Is the highest priority alerts still firing? Is customer impact confirmed? Are related services showing symptoms? We are trying to take all of these actions. Then finally, we are trying to give some incident commander notes: current status, customer impact, suspected root cause, mitigation started, owner, next update time. Now let's look at this particular file real quick. Cat reports final incident dot md. Press enter. This particular final report is something you actually imagine using in a real workflow. It gives the incident commander a starting point. It summarizes alert storm. For example, if you can see top incidents to investigate first. This final report is something you can actually imagine using in a real workflow. It gives the incident commander a starting point. It summarizes the alert storm. It gives AI reasoning. It also gives some validation steps. and it creates a clean artifact. In a real company, you could extend this by sending the report to Slack, or maybe creating a Jira ticket, or maybe opening a PagerDuty incident, adding links to Grafana dashboard, pulling logs from Loki, or pulling metrics from Prometheus. This is where the project becomes more powerful. The final last step is human validation. Now let's do that real quick. I am going to clear the screen and I would like to run some simple commands once again just to verify. Now let's try to validate this. I'm going to check PostgreSDB into this alert summary.md file. Press enter. Here we can see PostgreSDB 15 alerts, service PostgreSDB, max risk score is 445. The AI may recommend PostgreSDB or maybe checkout service as the highest priority, but we should not accept it blindly. We go back to the pre-AI summary. Do we see any kind of production alerts, customer impacts, or critical services? Do the scores support the recommendation? This is the same principle that we are trying to apply from project 1. AI helps us reason faster, but we as human beings, we need to validate that. I can see 14 different alerts in the checkout service. Now, let's try to summarize what we built today. This entire project can be summarized in 4 different steps. First, we started with alert chaos. We applied engineering logic here. AI helped us reason about priorities. And finally, humans validated the results. This is probably the most important lessons from both AI projects. Most people start with AI first. We started with engineering. Better inputs, better context, and also better outcomes. Then AI will become very, very useful. Lesson number 2. Not all alerts are equal. A database outage in production with customer impact should never be treated the same as a CPU warning in a development environment. Lesson number 3. Monitoring tools are very good at telling us that something happened. They are not always good at telling us what to do first. That's where triage becomes valuable. Lesson number 4. AI is really good at summarizing information. AI is also good at finding relationships, also good at organizing chaos, but AI should not be deciding what changes happen in production. Humans own that responsibility. This was project 2 in this AI for DevOps series. Next, we can go into several directions. AI Terraform Reviewer, as I said, AI Runbook Assistant. Let me know in the comments which one you want next. If you found value in this project, hit like and subscribe. And if you want the complete source code, comment triage, and also remember the challenge 100 comments on this particular video. If we get enough comments on this video, I'll make the full project public. Thank you for watching and see you in the next video.